Okay, let's unpack this. We talk about technology moving fast all the time.
Yeah,
It's almost a cliche at this point, right?
it really
You
is.
get a new phone, it's faster, a new app, it's smarter. We sort of roll our eyes at the marketing hype, but the research we have in front of us today, it suggests we are way past just moving fast.
We really are. Look, hype fatigue is a real thing, and it's a valid defense mechanism. If you believed every press release, you'd burn out. But if you look at the hard data, specifically this forecast from ARK Invest for 2026, we aren't just seeing individual breakthroughs anymore.
Yeah.
We're witnessing what the researchers call a technological convergence.
Right, the Great Acceleration.
Yeah.
That is the title of our deep dive today. And just to set the stakes here, because I think the numbers are, frankly, mind-boggling. The source material is projecting that global real GDP growth,
Yeah.
which usually just putters along at a consensus of about 3%, could jump to over 7% annually by 2030.
Which is massive.
It's historically massive. I mean, that is the kind of acceleration we haven't seen since the peak of the Industrial Revolution. So the question on everyone's mind has to be how? How do you double the speed of the global economy in just a few years?
Right.
What is driving that kind of explosive value creation?
Well, it's not just one thing, and that is the key to this entire deep dive. It's the collision of 5 specific innovation platforms.
Yeah.
You've got artificial intelligence, public blockchains, multiomics, robotics, and energy storage.
Okay.
And the mission for us today is to connect the dots. We need to see how these aren't separate silos anymore. AI is making better robots, and the robots are building better energy systems, and those energy systems are powering the AI. It's a flywheel.
A flywheel that is spinning faster and faster. So let's
Yeah.
start with the engine of that flywheel, the central dynamo, as the report calls it, artificial intelligence.
Absolutely. AI is the organizing force here. But what's fascinating is that the headline isn't just AI is getting smarter. We know that.
Yeah.
The headline is that AI is getting cheaper, historically cheaper.
You know, I saw this stat and I had to double check it. We're talking about inference costs.
Right, and let's define that. Training a model is teaching it. That costs billions. But inference is the cost to actually run the model, to ask it a question and get an answer. That cost is what determines if a technology changes the world.
And the sources say that the cost to achieve performance equivalent to GPT-4 dropped by nearly 100x so, essentially 99% between late 2024 and late 2025.
Just think of the implications of that. When a resource drops in price by 99%, it moves from being a luxury good to a utility.
Yeah.
It becomes like electricity or water. You don't think about turning on a light switch because it costs pennies. We are approaching that point with intelligence. This democratizes access in a way we haven't seen before. It means AI stops being this niche tool for tech companies and starts being embedded in, well, literally everything.
So we stop hoarding it. We use it for everything because the marginal cost is effectively zero. And that cost collapse is fueling a shift in how we actually use this stuff. We've been in what they call the chatbot era, right?
Right.
I type a prompt, the bot gives me text, it's a call and response. But the research says we are graduating to the agentic era.
This is a critical distinction, and I want to make sure we nail this because it changes the user experience entirely. In the chatbot era, you are the pilot. You're telling the AI what to do step by step.
They have to integrate the output.
Exactly. In the agentic era, the AI is the pilot. You give it a goal, not a task.
So instead of saying, write an email to my travel agent, I say, plan a trip to Japan for under $5,000 in May.
Precisely. And the agent goes off and autonomously executes these complex workflows to make that happen. It browses the web, it checks flights, it compares hotels, reads reviews, maybe it even negotiates a rate.
There was a specific detail on this that blew my mind, just on capability. The duration of tasks that these agents can handle has jumped from about 1 minute to over 10 minutes.
That doesn't sound like a lot of time. To a human, 10 minutes is a coffee break. But in computer time, that is an eternity. A 10-minute workflow allows for incredibly complex decision-making. It allows the AI to hit a roadblock, back up, try a different path, and solve the problem without asking you for help.
And the real-world impact of that, they call it transaction compression.
Yes. Think about buying something online today. You have to research, compare prices, find the link, fill out the form, enter your credit card.
Find your address.
Exactly. That might take an hour of your time, satorically. An AI purchasing agent can compress that entire journey from I need this to it's bought down to about 90 seconds.
That is efficiency on a scale that is hard to wrap your head around. It removes so much friction from the economy. But, and here's the catch, you can't have this software revolution without some serious hardware. We are talking about a physical build-out, aren't we?
We are. The cloud is actually a very physical place. It's full of hot metal and wires. To support this agentic era, we're seeing an infrastructure boom that rivals, the construction of the interstate highway system. The projection is that data center investment will hit $1.4 trillion by 2030.
1.4 trillion. That is a staggering amount of concrete and silicon. And you look at who is spending this money, the hyperscalers. Microsoft, Google, Amazon, Meta. They are pouring hundreds of billions into custom silicon and massive server farms.
Because they know that whoever owns the infrastructure owns the future of intelligence. They're building the factories of the 21st century. In the Industrial Revolution, if you own the railroads, you won. In the agentic era, if you own the compute, you win. But here's where it gets really interesting. AI doesn't just want to live in a server rack. It wants to move.
Right. And that brings us to the second platform, robotics. This is AI getting a body.
Precisely. For a long time, robots were these blind, dumb machines that did the same weld on a car assembly line 1,000,000 times. If you moved the car an inch, the robot would weld the air. It had no context. But now, thanks to that cheap AI inference we just talked about, robots can see, they can learn, and they can adapt.
And we are seeing this first in industrial automation. The robot density in factories has apparently doubled in the last 7 years.
It has. Amazon is the prime example here. They now have over 1 million robots deployed. And these aren't just moving boxes. They're orchestrating entire logistics flows. But the holy grail isn't the factory arm. It's the humanoid.
The sci-fi dream. Robots that look like us. We've all seen the videos of Tesla's Optimus and Figure AI. But I have to play devil's advocate here. Why the humanoid form factor? Why make it look like a person? Wheels seem way more efficient than legs.
It's a great question, and it comes down to the environment. The world is built for people. Stairs, door handles, tools, countertops, the width of a hallway. Our entire infrastructure is architected for the bipedal human form. If you want a general-purpose robot that can operate anywhere a human can, without rebuilding your whole factory or house, the humanoid shape is the most versatile.
But it's also the hardest to build, right?
Significantly harder. The report notes that a humanoid robot is about 100 times more complex to operate than a robotaxi.
100 times. Why?
It's the degrees of freedom. A robotaxi basically steers and brakes. It moves on a 2D plane. A humanoid has arms, legs, fingers, wrists, balance. It has to manipulate objects.
And the tasks are more diverse.
Infinitely more diverse.
Yeah.
A robotaxi just has to drive. A humanoid might have to fold laundry, then cook an egg, then fix a leak under the sink. The software challenge is exponential.
Speaking of folding laundry, let's talk about the economics of that, because there is a number here that stopped me in my tracks. A humanoid robot in the home could add around $62,000 to GDP annually. How does a robot doing my chores add to the gross domestic product?
This connects back to how we measure value. Right now, if you spend your Saturday cleaning your house and mowing the lawn, that is unpaid labor. It's shadow work.
Right.
It doesn't show up in GDP because no money changed hands.
Yeah.
But if you had a robot doing that and you paid for the robot service, or if that robot freed you up to do other productive work, suddenly that invisible value becomes monetized.
So it's bringing the shadow economy of household labor into the formal economy.
Exactly. It's a fundamental shift in how we value time. If you can outsource the drudgery to a machine for pennies on the dollar, your time becomes incredibly valuable. And speaking of moving things, we have to talk about the other side of robotics. Moving things around outside. Autonomous logistics.
Robo-taxis and delivery drones. The opportunity here is estimated at $28 trillion. And again, it comes down to cost. The report says autonomous delivery could reduce last-mile costs by 90%.
From dollars to cents. Think about getting a pizza delivered. Most of that cost is paying the human driver.
Of course.
If you remove the driver, the cost collapses.
And when the cost drops that much, it changes behavior. Suddenly, getting a single toothbrush delivered instantly isn't a luxury, it's just how the world works.
Exactly. We stop batching our errands. The physical world becomes as fluid as the digital world.
So we have AI thinking, we have robots moving, but what about us, the biological humans in this equation? That brings us to the third platform, multiomics.
This is maybe the most personal of all the convergences. Multiomics is essentially the intersection of biology and technology. It's treating the human body as a data problem.
And the data source is our DNA. The cost curve here is even steeper than in computing.
It's incredible. In 2001, the Human Genome Project spent about $100 million to sequence a single genome. It was a massive global effort. Today, in 2025, it's around $200, and it's heading toward $100.
So for the price of a nice dinner, you can unlock your entire genetic code.
And once you have that data, you can apply AI to it. This is solving the biggest problem in medicine, drug discovery. Right now, finding a new drug is like finding a needle in a haystack. It takes a decade, costs billions, and most of them fail in clinical trials.
And the report says AI can reduce that development time by 25% and cut costs by half.
Because AI can simulate how a molecule will interact with the body before you ever mix a chemical in a lab. It turns biology into an engineering discipline. You fail fast in the simulation so you can succeed in the real world. But the real revolution here isn't just cheaper drugs. It's the shift from treatment to cure.
Cures versus treatments. This feels like a massive business model disruption.
It is. The traditional pharmaceutical model is built on maintenance. You take a pill for your cholesterol or your blood pressure every day for the rest of your life. That is a steady, predictable revenue stream. Investors love it.
Sure.
But technologies like CRISPR gene editing offer the potential to actually fix the genetic error. One shot, and you are cured.
Which is amazing for the patient, obviously. But how does that work economically? If you cure your customer, you lose your customer.
That is the big question. A cure has a massive upfront value, potentially millions of dollars in value to the patient in the healthcare system, because you're avoiding a lifetime of hospital visits and pills.
Oh, okay.
So the business model has to shift from selling pills to selling outcomes. We are looking at a future where a single intervention could be worth $2 million up front because it saves $10 million down the road.
It's a complete restructuring of healthcare economics. It turns health into an asset you invest in rather than a service you rent. Okay, so we've covered the brain, which is AI, the body, robotics, and the code, multiomics. Now we need the rails and the fuel. Let's talk about the financial layer.
Public blockchains. Now, I know when people hear crypto, they often think of speculation or volatility, or they think of people trading pictures of monkeys.
Right.
But in this context, we need to view it as the Internet of value.
The report specifically mentions Bitcoin maturing into an institutional asset.
Yes, the digital gold thesis. With ETFs and major institutions buying in, Bitcoin has solidified its place as a store of value. It's the anchor. But beyond Bitcoin, the real utility for this great acceleration comes from smart contracts and tokenization.
Tokenization, that's putting real-world stuff on the blockchain, right?
Exactly. Bonds, real estate, art. The idea is to take these illiquid assets and make them tradable and programmable. The potential market size here is cited at $16 trillion by 2030.
And we're seeing this with stablecoins already. I saw a stat that stablecoin transaction volume hit $1.4 trillion in a single month. That is more than Visa and PayPal combined.
It is. And that tells you that people, and increasingly businesses, are using these rails for actual payments, not just trading. It's faster, it's 2247, and it's global. But here is the critical connection to AI. If we go back to our AI agents, if an AI agent needs to buy something or sign a contract, it's probably not going to walk into a bank branch and open an account.
Right. It can't provide a driver's license.
Exactly. AI agents are digital natives. They need a digital native currency. They are going to use digital wallets and stablecoins. Blockchains provide the automated, programmable financial rails that the agentic economy needs to function.
That makes perfect sense. The robots need a bank account, and crypto is it. But all of this, the data centers, the robots, the blockchain transactions, it all needs power. And AI is hungry.
Voracious. This is the bottleneck. You cannot have the grid acceleration without energy. And that is where the fifth platform comes in, energy storage.
We have this concept of Wright's law again.
Right. Wright's law essentially observes that for every doubling of production, costs fall by a fixed percentage. We're seeing this with solar panels and, crucially, with batteries. The cost of storing energy is plummeting, which makes renewable energy reliable.
But solar and wind are intermittent. The sun doesn't always shine, and these massive data centers need to run 2007, 365.
Which is why we are seeing a nuclear renaissance. And it's not the government leading it, it's the tech giants. Microsoft, Google, Amazon, they're investing in small modular reactors, or SMRs.
Wow.
We're even seeing plans to restart dormant plants like 3 Mile Island, specifically to guarantee baseload power for AI.
That is irony of the highest order. The most futuristic technology, AI, is bringing the nuclear industry back from the dead.
It's necessary. If you want intelligence, you need electrons, and you need them to be carbon-free and constant. It's a pragmatic move.
So bringing it all together, we've got these 5 platforms: AI, robotics, multiomics, blockchain, energy. But the magic isn't in the silos, is it?
No. The magic is in the convergence. That is the outro to our deep dive here. It's how they amplify one another.
Right.
Think about it. You use AI to design a better battery material.
Okay.
That's multiomics and AI working together. That better battery powers a more efficient humanoid robot. That robot builds a solar farm cheaper. That solar farm powers the data center that runs the AI.
It's a positive feedback loop.
And because of that feedback loop, the timeline is compressing. Changes that used to take decades, like the transition from horses to cars, might happen in years. This is the great acceleration.
It's exciting, but it's also a lot to process. It feels like the ground is shifting under our feet.
It is. And it raises a final, somewhat provocative thought for everyone listening.
Lay it on us.
If we're moving toward a world where AI agents handle the cognitive labor, the organizing, the planning, the buying, and humanoid robots handle the physical labor, the folding, the building, the driving.
Yeah.
And if we move from treatments to cures, reducing the need for constant medical care, what is left?
That's the billion-dollar question. What do we do with our time?
Exactly. We are facing a fundamental restructuring of how we value human time and labor. If unpaid work, like household chores, becomes GDP and expertise is democratized by AI, how do you define your value? How do you prepare for an economy where the scarcity isn't labor or knowledge, but perhaps purpose or creativity or human connection?
It sounds like we are moving from an economy of how to an economy of why.
That's a beautiful way to put it.
That is the question we're going to leave you with today. The technology is accelerating at 7% a year.
Right.
But the biggest adaptation isn't going to be software updates. It's going to be us.
Absolutely. The human element is the final frontier.
Thanks for joining us on this deep dive into the future. It's coming faster than you think.
See you next time.